Okay, so in this video, we're going to work on finding inverses algebraically from equations using these 6 steps that are printed here on the front. And we're going to go over those steps as we work through the examples together, so you'll have an opportunity to see those in context. So in example 1, we're looking at inverses of linear and cubic functions. And our step 1 that was on the front was to use the horizontal line test to determine if the function has an inverse. And the reason we do that first is because if the function doesn't have an inverse that's also a function, then there's no point in trying to find the equation of the inverse. So we always do that first just to make sure we're not wasting our time. When we're looking at linear, these two are linear, or this one, example C, which is a cubic function, when we're looking at those, they're parent graphs for linear are diagonal lines. The cubic is that vertical wiggle, and they all pass the horizontal line test. So no worries about step number 1. Okay, then step number 2 is to replace that f of x notation with y equals. So we're going to go ahead and do that in this example A. So we're going to change that f of x to a y equals 2x minus 4. And then the next step is to switch the x and the y. And if you remember from our last lesson where we learned about the graphic relationship between a function and its inverse, we saw that the ordered pairs reverse the x and y position for a function and its inverse. So all we're doing in the equation is that same thing. We're switching the position of the x and the y to create the inverse. And so that is going to give us an x equals 2y minus 4 because we reversed the x and y position. Okay, now our next step, we did replace f of x with y. We switched the x and the y's. Now we're going to solve for y and simplify in step number 4. So to get this y by itself, I'm going to go ahead and add 4 to each side of this equation. And then I'll have x plus 4 is equal to 2y. And then still trying to get the y by itself, I'm going to divide both sides by 2, and then when I simplify, I'll have 1/2 x plus, and then 4 divided by 2 is 2, and then on this side the 2's cancel, and I'm left with a y equals. Okay, that brings us to step number 5, which is to replace that y with our inverse notation. And so I'll have, instead of y equals, f inverse of x equals, right? So I'm changing out the y with this inverse notation, and that'll be equal to 1/2 x plus 2. And that is the equation of my inverse. Now, the last step, number 6, is to restrict the domain if needed. And because the domain and range of a linear function are both all real numbers, this inverse, it has the same all real numbers for its domain and range. So nothing needs to be restricted in example A. Okay, so go ahead and pause the video, and I'd like you to try to find the equation of the inverse in example B on your own. And then when you've given it a try, go ahead and turn the video back on, and we'll go over that one together. Okay, so in example B, it passes the horizontal line test. So I'm going to go ahead and replace my inverse notation with y equals. So y equals 5 minus 3x, all divided by 2. Okay, then my next step is to switch the x and the y, and that will give me x equals 5 minus 3 times y, all divided by 2. Okay, then I want to solve for y, so I'm going to multiply both sides by 2, so that these 2's cancel, and then I'll be left with a 2x is equal to 5 minus 3y. Then still trying to get that y by itself, I'm going to subtract 5 from both sides, and I'll have 2x minus 5 is equal to negative 3y. And then divide both sides by negative 3, and negative 2/3 x plus 5/3 is equal to y. Okay, and now my y is by itself. I can replace that y equals with my inverse notation. So f inverse of x is now equal to negative 2/3 x plus 5/3. Okay, and I don't need to restrict the domain or range because the inverse and its original function are both linear, and their domain and range is all real numbers. Okay, so go ahead and pause the video and try this cubic example in C on your own, and then when you're ready to check your answer, go ahead and turn it back on and we'll resume. Okay, so in example C, this passes the horizontal line test, so I'm going to go ahead and replace that that function notation with y equals. So 8 minus x cubed. And then my next step is to switch the x and the y. So I'll have x equals 8 minus y cubed. Okay, then I want to solve for y, so I'm going to subtract 8 from both sides, and I'll have x minus 8 is equal to negative y cubed. And then I'm going to divide both sides by negative 1 to get that y cubed by itself. So I'll have negative x plus 8 is equal to y cubed. Okay, to undo a cube, I have to do the inverse operation, which would be a cube root. So I'm going to take the cube root of both sides, and then I'll have the cube root of the quantity negative x plus 8 is equal to y. Okay, now if you were to sketch this graph, right, you would need to, like we learned in our transformations lessons, that b is a negative 1, you'd factor that out, and you'd have a negative x, let's write it down here, so you'd have negative and then x minus 8 in parentheses, right? So that would be a shift translation to the right 8 units, and then reflected in the y-axis when you would go to sketch that graph. So you could write it in this form, you could write it in this form. If you recognize that symmetry for the cube root function, since it's an odd function, which we'll be talking about in a later lesson, this would also be equivalent to if we wrote our inverse notation. We could pull that negative reflection out front and have negative cube root of the quantity x minus 8. So all 3 of these forms would be acceptable. They're all equivalent. They produce the same graph. So however you want to simplify that down to its final form for your inverse notation is totally up to you.